Hi everyone! Today we're working on word problems with the quadratic formula. To refresh your memory and get the song stuck in your head, the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So let's look how we can use this formula with a word problem. Let's say the word problem said, a kicker punts a football from a height of 2.5 feet above the ground with an initial velocity of 45 feet per second. The height of the football can be modeled by h equals negative 16t squared plus 45t plus 2.5, where h is the height in feet and t is time in seconds. The football reaches its apex and descends until it is caught 5.5 feet above the ground. How long was the football in the air? Before we start to solve this problem, let's talk about where this formula came from. So if we look at this, h equals negative 16t squared plus 45t plus 2.5. Negative 16t squared is gravity acting on an object that's either dropped or somehow launched via a kick, a throw, some kind of a launcher like a catapult, but then doesn't have anything acting on it once it's in the air. So it doesn't have some kind of an engine or a motor that keeps pushing it. It just is initially thrown, dropped, or launched, and then it goes through the air. In that case, negative 16t squared would be the force of gravity acting on that. This number, 45, comes from its initial velocity. Its initial velocity is the force that you're using to make it go, how fast it's going in the air. It is going 45 feet per second in the air. So 45 goes here. And then 2.5 is your starting or initial height. So our starting or initial height is 2.5 feet. That's the point where the kicker's foot actually connects with the football. The football is 2.5 feet above the ground when it is kicked. So that goes here. Okay, we're trying to find when it reaches 5.5 feet above the ground. So we're trying to find a height of 5.5 feet. So to solve this problem, we're going to put 5.5 in for h, and then we're going to solve for t. Okay, so when you do that, you wind up with 5.5 equals negative 16t squared plus 45t plus 2.5. This is quadratic because it's got t squared, and for quadratic equations, we can always use the quadratic formula as long as we make one side equal 0 first. So I have to move this 5.5 so that that side of the equation will be 0. I'm going to subtract 5.5 from both sides. And I wind up with 0 equals negative 16t squared plus 45t minus 3. This is now a quadratic equation that equals 0, so now I can find a, b, and c in order to use the quadratic formula. A is the coefficient of t squared, so in this case, a is negative 16. B is the coefficient of t, so here b is 45, and c is your constant, which here is negative 3. Now I'm going to use a, b, and c and plug them into the formula. So in the formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. And yes, I am trying to get that stuck in your head, because then maybe you'll remember it next year. So we plug things in. For b, we're putting 45. So this is negative 45 plus or minus the square root. We have b again, so 45 squared minus 4 times a, which is negative 16, times c, which is negative 3. And then all of that is over 2 times a, which is negative 16. Okay, we're going to simplify that. This negative 45 is negative 45 plus or minus 45 squared is 2,025. And then negative 4 times negative 16 times negative 3 would be negative 192. It's negative because a negative times a negative is a positive, and then there's a third negative, so that makes it negative again. And that's all over negative 32, because 2 times negative 16 is negative 32. Okay, inside the square root, we're going to do 2,025 minus 192, and we get 1,833. So now we have negative 45 plus or minus the square root of 1,833 all over negative 32. Okay, so now we're going to find the square root of 1,833, which is about 42.8. So now I'm at negative 45 plus or minus 42.8 all over negative 32. So remember, plus or minus means you have to do them both. So I have to do negative 45 plus 42.8 divided by negative 32. And I also have to do negative 45 minus 42.8 divided by negative 32. Okay. When you do, I'm going to just do an arrow up here. When you do negative 45 plus 42.8, you get negative 2.2. So this is negative 2.2 over negative 32. And that simplifies to 0.06875. I'm going to round to the hundredths. So to the hundredths, this is about 0.07. And then I also have to do it with minus. So negative 45 minus 42.8 is negative 87.8 over negative 32. And when I divide that, I get 2.74375. If I round to the nearest hundredth, that goes to about 2.74. Okay, so I have two answers. I have 0.07 and 2.74. That means the football's actually going to be at 5.5 feet in two different places. After 0.07 seconds, it'll be 5.5 feet above the ground. And after 2.74 seconds, it'll be 5.5 feet above the ground. This makes sense when you think about the path of a football. So you've got the person kicking the football. The football leaves their foot, goes over here, reaches the apex, goes down, and then you have the person catching the football. Here, we know that's 2.5 feet above the ground. And here, I know that this is 5.5 feet above the ground when the football's caught. This is what we're trying to find, because we're going to try to find how many seconds it takes to get here to where the football's caught. Now, why are there two spots though? Why do I have two different times? Well, that's because there's actually two spots where the football's at 5.5 feet. Here it's at 5.5 feet, but it's also at 5.5 feet over here. It crosses 5.5 feet going up, reaches the apex, goes back down, and then it's caught. This one, the first time it reaches 5.5 feet on its upward trajectory, that's after 0.07 seconds. So 0.07 seconds after it gets kicked, it'll be 5.5 feet up. Then it'll keep going, reach its apex, start coming back down, and then this is the 2.74 seconds. The second time it reaches 5.5 feet on its way back down. So this is what we're actually looking for, because that's how long it's in the air before it's caught. So the football is in the air for 2.74 seconds. All right, all of your homework is going to be word problems. If you get confused, please, please, please email me. Have a wonderful day.